Alrighty, so week 4? No, 3. Are we doing 3 or 4? Week 3. Oh, so we're still not at the bag. We're still not at the bag yet. Okay, so classes array encapsulation. Okay. So what do we cover? We covered header files, pre and post conditions, and I have the solution for that thing posted under week. No, I don't have a solution for that because pretty much it was pretty straightforward. I don't have a solution for that. But for these other ones, P2, P3, I believe I have the solutions posted in the later weeks. So if you get stuck, move like a couple weeks forward and you'll see it. All right, so I got the header files and the if and def business out of the way. Do you have any questions on that stuff? All good? Okay, so we're not going to do any more of that stuff for the rest of the semester, I can promise you. What we're starting with this week is array encapsulation, a little bit about object-oriented programming. Okay, if you haven't done any object-oriented programming, okay, here it is. So let's see. So what I'm going to do is I'm going to go a little bit through these two PowerPoints, Chapter 2, Chapter 3 real quick. And they're kind of long, I think, so I'm kind of not going to spend too much time on each slide because it's better to give you some real examples. Okay, so I probably mentioned to you the difference between ADT, abstract data type, and data structure. So, do you remember the difference? Richard, what's what?
Abstract data type was way stored in memory, and the structure is the implementation.
The abstract data type is the real world problem. Like we're going to have a line of people, how we're going to model that in the computer science world, in the programming language, is the data structures, right? So if you have a line of people, you have people coming at the end and then leaving at the front, that's a queue. If you have a stack of plates, you know, you're putting the plates on top, right? And when you start washing them, you wash them from the topmost first, right? That's a stack. If you have just a collection of items that are unordered, you can have repeaters. That will be called a bag, right? And we have data structures for a bag. If you have like some kind of an organizational chart, right? That will be the abstract data type, and the computer science representation or implementation of that will be the data structure, right? So the abstract data type is the real world problem or thing that we're trying to solve, and the data structure is the computer science-y way of doing that. Okay, so that's basically what this is, and I guess this goes over like the basic data types in C++. So these are the basic data types, are like the integer and the character and the float and the double, right? Those are the primitive data types, so-called. Two's complement representation, I'm going to skip that. There's some other ones that I'll show you more. Well, basically the two's complement is a way for you to add and subtract both by just using binary, okay? Yeah. Problem with integer representation, that one's interesting. Let me see if I have it here, right here. So there's a link here that I have of floating point discrepancies. So you may have noticed, maybe you haven't, if you haven't done this long enough, but sometimes you'll do some kind of a decimal number operations in computer science, and you're going to have something like 2 plus 2, and it'll come out to like 3.9999 or some weird number like that. Okay, And the reason for that is because, and I'm talking about floats, right? Decimals, I mean, integers are okay, but decimal numbers have issues when we're doing them in computer science or in programming. And this is the reason why. And the reason why, I'll let you read through this in detail. I'll give you the short version. Is basically the same way you have irrational numbers in our decimal number system. You guys know what an irrational number is? Cannot be expressed as a ratio of two numbers, and in other words, it never has, you know, some kind of a repeating pattern. If you have, let's say you have something like 3.14, like if this is pi, right? I can't remember what the whole thing is, but basically it goes on like 3.143, I don't know what it is, 7, and then 3, 1, 2, right? Whatever it is. There's never like a pattern that repeats. Okay, so if we had this thing as 3.143 and then it was like another 143 and then it's a 143, then you can kind of accurately represent this thing as just this, right? Okay, but if you can't, then it's an irrational number. You can't really round it down to, you know, just a chunk, a group of digits. And a similar thing happens in computer science when we do binary numbers. Okay, and the reason for this is because you cannot accurately represent a decimal number as a binary. Okay, there's never really, it turns into like an irrational binary number. You can't really accurately round it down to like a chunk of digits. So you might have like a 2.5, yeah, 2.5 in decimal is just 2.5, but if you're trying to express this thing in binary, you were like 0.011 dot 0.11, and then there's no repeating pattern, so you can't really round it down to a specific. You cannot express a decimal number exactly using binary, and that's the floating point discrepancy. Okay. I have some videos in there, and I have an example so you can look through this.
Is that in every language?
Yeah, yeah. That's just just because computers use binary, we're forced to use this, right? So basically, if you're trying to express 1.7, you basically are going to end up with like 1.6875, really, all right? And it's not exact. And that's the floating point numbers. So most floating point numbers that a computer can represent are just approximations. Sometimes these approximations are good enough. Many times they're not. Okay, and yeah, that works in C++ and Python and Java, pick the language. Okay, so that's the floating point discrepancy that this is talking about. Float data and the floating point representation, how you convert from one to the other. I'll let you read through that on your own time. And Boolean data type.
I'm sorry,
yeah.
Let me step back,
Mm-hmm.
because I watched the video on that,
Mm-hmm.
and then after he takes it and he converts it,
Mm-hmm.
then he adds 127 to it. And in the example, 0.2 was the fraction, which was a repeating array, and
You're talking about this here, this video here?
yeah, the video that you indicate right there.
Mm-hmm.
And with his example, he adds 127 and then
converting 5.2 into the floating point representation.
All right, let's watch this thing.
Number 5 can be represented in a binary as 1, 0, 1. 0.2, we are converting to binary by multiplying it by 2. 0.2 times 2 is 0.4, 0. 0.4 times 2 is 0.8, 0. 0.8 times 2 is 1.6. 1.6 times 2 is 1.2. So now we see that we came back to 0.2, which means we'll repeat the pattern. So we know that 5.2 can be represented in a binary as 101.00110011, and it goes forever. So now we are converting this to the floating point representation. the first step is moving this dot just before the very first one. So it's 1, 2. We are moving this by 2 positions. It is 1.0100110011, and so the exponential is plus 2. So now there's a trick that we have to add 127 to our exponential, which is 2. It is 129, which in a binary is 1 followed by 6 zeros and 1.
So
Now we are building flow.
I guess his trick is the 127 constant for anything?
Yes. Yes.
Floating point number. The
And by
first
the way,
part,
the 127 is if you have a binary, right? If you have 1, 2, 3, 4, 5, 6, 7, 8, right? The first one is, it's hard. These are hard to write. So the first one is 1, and then the next one is 2, and then the next one is 4, and then the next one is 8. Right, and then the next one is 16, next one is 16, 16, 16, that's what I meant. The next one is 32, then the next one is 64. Right, so where does it get to 128? So 64, 64, and then this one is 128, and the sum of these digits is 127. So it's basically this. If this one here, if this being 1 is 128, then the sum of all the preceding ones is 127. Okay, and that has to do with like the signed and unsigned binary, right? Where you have basically you're trying to represent a number as either a positive or negative, and this first bit doesn't count because this first bit is going to indicate whether this number here is going to be a positive or negative. Okay, and that's where the 127 comes from.
Those other ones add up to 127?
Yeah, if we do 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1, that will come up to 127. And then when you add, so basically if you have well, let's do,
I'm sorry, I thought the binary would be 100000001. That would be 127.
0, 0, 0, 0, 0, 0. No, that would be
That would be 128 plus 1 in the very first column, so that was 1000000.
watch 64. It hides it. Calculator. No, Excel's better. Where's mine? And I do 64, 32, 16. 8, 4, 2, 1, and I sum these. That's the 127, right? So it basically it comes down to this. It's like if you have a single binary digits, so it's either 0 or 1, and you want to add 1 to this, well then it's a 0, 1. Oops, sorry, 1, 0. Now it's a 2. Same thing. If you have a 0, 1, 2, 3, that's a 4, and then 1, 2, 3, 4, right? This number right here is a 127. And if you add 1 to this, and then it becomes 128, which is there, right? It all comes from that. So yeah, it comes from like trying to represent a number as either positive or negative. So we're not really using all of the 8 bits. The first bit is used to tell it whether it's a positive or negative number, and the rest of the bits, yeah, that's something that we cover in assembly language. Yep, chapter 1, I think, or 2 maybe. It goes over in great depth in like all these different numbers and how we do the conversions.
This is kind of the surface of it, right?
Huh?
This is kind of the surface.
Yeah. We're not going to go like too much in depth on this topic because it's really not. It's not really what this class is about. Where did it go? The other one. Huh? You think so? I'm trying to find where the other one is. I hit it. Oh, it's on a different screen. Okay, but anyway, that's how we convert, back and forward. So watch this video, look through the PowerPoints, it will make sense. I just don't want to spend too much time on it. Okay, just I want you to be aware that there's, sometimes you will have a decimal number that you could, there is some kind of a pattern like this that you could see that repeats, and in that case you could kind of accurately represent it as a binary number. Otherwise, you can't. Okay, and that's why many times when you have a decimal number, it does not really translate to a binary, or the binary representation of that decimal does not translate to the real decimal that you're going for. So let me close this, go back to that PowerPoint thingy. Problems with real representation, that is at. Okay, simple data types. So there's another primitive data type, if you want to call it that, the Boolean. In other languages, Boolean is its own data type. In C++, it's actually really just an integer, 0 and 1. 1 is true, 0 is false. We can define our own data types using typedef in C++. Basically, just like most things, you can do all kinds of stuff with C++. And this typedef double basically defines the word real to have the same exact meaning as the data type double. So if you don't want to use double for the rest of the program, you want to call it real, you say typedef double real, and now real means double. Okay, and that comes in handy if you're working with like classes and structures and stuff like that. So basically, it reduces the amount of things that you're gonna write. Right? So you could have some kind of, we haven't covered classes a whole lot yet, but you can have some really long class name, like numbers of apples or whatever, and then you can define your own word that represents that class or object shorter. Okay. So that's that. That's really the typedef, and there's also enums, which we really don't care about too much right now. Okay, and then pointers. So we covered pointers in C++ a bit. Okay, and pointers are just special variables that are equal to the memory address of another variable. Okay, so instead of like int where it's equal to an actual integer value, or char, which is equal to some character, the pointer, which is expressed with a little asterisk, is equal to the memory address of another variable. It could be another primitive type variable. It could be another object that you create using a class. Okay, and we are going to be using pointers a whole lot, because the way we're going to create arrays in C++ requires pointers. Okay, in order for us to basically create an array of whatever size we want during runtime, which is called the dynamic memory allocation, we need to use pointers. Okay, and you'll see it when I show you the extra example. It will make sense. Okay, and that's what this is. Yeah, so this is how a pointer is expressed. If you have an asterisk pointer is equal to some value, what you're actually, so let's say J pointer refers to variable A. Okay, in fact, J pointer, I pointer. Oh yeah, there you go. So if you look at this picture, J pointer, right? There is a memory address of, this is the variable I right here. Okay, and the contents in memory for that variable I is 44. Okay, and the memory address of that variable is this number right here, right? So there's many memory slots in memory. This is one of them. Okay, the reason why, notice how the memory addresses are offset by 4, right? So there's variable I and there's variable J. That is the case when you have some kind of a data type which takes up 4 bytes of memory. Like for example, integers take up 4 bytes of memory. If you have a float, I think it also 4 bytes of memory. When you go to double starts using 8 bytes of memory. Okay, so if you have a series of doubles declared, then the memory locations are going to be offset from each other by plus 8. If you have an integer, it will be by plus 4. If you have a character, it will be plus 1. Okay? Anyway, the main thing is you have a variable, you have some content in memory, and you have a memory address. Okay? So when you initially, they're not showing the syntax, but what they have done is they have said, okay, this I pointer here is equal to the memory address of I. And basically, the way you do that is you just say, so let's say this is my int I, right, is equal to 0, and then I has some kind of a memory address like 0, what do they have it as? BFFFDF, right? 0xBFDDD, what is it? 20, right? That's the memory address of I. Memory address of I, of variable I. Okay, then after that, what we're going to do is we're going to say, what is it called? I pointer. We're going to say int asterisk I pointer. Okay, so now this declares I pointer to be of the pointer type, or it's to be a pointer to an integer variable. Okay, and if you actually look at I pointer itself will have some memory address too. So just like my variable I has some kind of a memory address for this slot in memory, I pointer will also have some kind of a memory address next to it. But we really don't care about that. Okay, unless you start doing pointer to a pointer, which you can also do in C++, but we're not going to go there. Okay, so anyway, the moral of the story is this thing initially, whatever's stored in the memory location, or the memory slot for J pointer initially is like in C++, just like usual, some garbage number.
Yeah.
All right, but as soon as we do I pointer equals %I, now the information that is stored in the memory slot of J pointer becomes equal to this. Or in other words, this here, the D20 is the same as this one right here. Okay? So in other words, you have this thing referring to the same place in memory as I. And if you want to, you could change the content of I by just saying this. So if I go in there, so let's say, so originally I is equal to 0, so that means that instead of a 44 in here, we have a 0, right? And then as soon as I do asterisk I pointer is equal to 44, now this value right here that used to be 0 is now 44. Okay, so that's sort of the thing that we're doing. And in reality, we're not going to be doing this kind of a pointer things. We're going to use pointers in a slightly different way. Okay,
What do you use that for when,
we did this for, let's say, if you have a variable which is declared in one function, and let's say you have a variable declared in the main, right? That variable is local to the main, so it can only be seen and used and changed in the main. But if you want to, let's say, make a function that asks the user to enter input, and that input updates the content of the variable in the main, then you send it as a pointer into the function, and then the function can update, update the local variable. Okay, so yeah, which is kind of cool. It's useful. Okay, so the basic pointer operations, we'll get to that. Okay, yeah, the new is used when we're going to do dynamic memory allocation. We're going to use this to create arrays. So that's going to be the practical application. You want to declare an array, but you don't know what size the array is going to be until the program runs. So that is called dynamic memory allocation. When you declare the size of an array once the program is running, that's the dynamic memory allocation. Okay, and that's basically as far as this PowerPoint goes. And the next one, let's have a look at it. The next one is pointer pointer arithmetic, dynamic arrays, memory leaks. So let's look at this real quick. Okay, so more about data structures, abstract data types. I already kind of told you the difference. Arrays. Okay, so in case you forgot what arrays are, just basically a list of numbers or characters or whatever. Okay, in this class we're going to make arrays of objects also, and for that purpose we're going to need the dynamic memory allocation for arrays. Because if you're just creating a regular array and you want to run the program and then ask the user to enter how big the array is going to be, you could do that for just like a basic array. But if you're going to put that array, if you're going to encapsulate it, or you're going to put that array inside of an object, and then you're going to create a new object, and then upon creation, when the program runs, you're trying to resize the array or give it the size, then you cannot do it without a dynamic memory allocation or dynamic arrays. Okay, so this kind of reviews what arrays are, and in case you forgot, right, the arrays is basically some kind of a name. You have square brackets and you have indexes. The number that's in between the square bracket is called an index. If you have an array of 10 things, for example, then the index will go from 0 to 9, right? And it will not go to 10, because 10 will be 11 things, since we're starting at 0. Unlike Java and Python and a lot of these other higher level languages, C++ will not give you an error if you go out of range. So you can go and give it like index 55, and it won't tell you anything. It will just try to, it will try to do it, okay? So, and it won't work most of the times. Okay, so you can have a character array. Oh, and by the way, a character array is basically just, character array is just a bunch of characters. If you have this / null at the end, that is used for strings. So it's a way and a string is just a bunch of text. The way you're telling the compiler that this is the end of the string is by using this no character, the /0. So whether you have a string array, or a string data type, or you have a character array which ends with a /null, it's pretty much the same thing. Okay, except the string is an object. Okay. All right. So subscripts. Moving along. Out of range errors, right? There it is. Most C++ compilers do not default check indices for out of range. Okay, so sometimes, a lot of times, it will not work. Okay, the problem with C++ style arrays is that even when you do dynamic memory allocation, let's say you gave it an array of size 10, it's 10 for the rest of the program. Okay, you cannot go and make it 5 or 11 or 20 or whatever. You cannot. There's the data type of array in C++, or just like with most languages, if you have an array, it's fixed in size. There is other ways to have a structure. Or actually, an array is not a data type; it's a structure. So array is an example of a data structure. Okay. And there is another data structure called vector, and the vectors can be resized. So if you have a vector of size 10 and you're trying to add 1, make it 11, then the vector will automatically increase its own size to accommodate that. Multi-dimensional arrays, right? You can have an array represent like a spreadsheet, and it will look something like this, right? You'll have two square brackets, right? So if you want to think of it as like an Excel spreadsheet, it has rows, it has columns, okay? And you can have 3-dimensional arrays. That's what this thing is showing. You can have 4-dimensional arrays, 5-dimensional arrays. There's problems in math and physics that can require these kind of things. If you're doing like a matrix operations or different kinds of things like that, you might need to have multiple dimensions, okay? Array of array declarations, I'll skip that part for now. Memory allocations of 2D array, I'll skip that too. Dynamic arrays, that's interesting. Okay, so here's how a dynamic array works. Okay, so you have some kind of an array, int array pointer, right? And what this pointer, and this is why I was telling you we're going to be using pointers, because this is basically a pointer, right? Array pointer is equal to new int 6. So we're going to be doing this kind of stuff when the program runs. Okay, there's just no other way to do this in C++. Okay, Java does this pretty much the same exact thing, except they don't have a pointer. No pointer. Okay, it's built into the language. It has the new. You can do these kind of things, but without a pointer. Pointer arithmetic. Okay, so whether you have a pointer the way you have it this here, or you declare a regular array like you would, like int, square brackets, whatever, they both work pretty much the same. Okay, and I kind of show this in the CSIS45 class, but you can kind of tell it pointer plus plus, and that will automatically shift it down one memory slot. So if you have declared an array of integers and you say pointer plus plus, then we'll go plus 4 bytes in the memory location or the memory address. Okay, so that's built into the language. This new operator is used to create dynamic memory allocation. It's creating something as the program is running. The problem with C++ is that you could have memory leaks. So if you create a whole bunch of, let's say your program keeps creating new, like there's some kind of a loop in there, and you keep creating a new dynamic array every time you go through this loop, what will happen is the program will eventually just run out of memory. So what you have to do is, and it will either crash or the operating system will kill it. So what you want to do is you want to delete these pointers. Okay, so in the C++ language, there's a delete keyword which allows you to delete the arrays that you created so that there isn't this memory leak. Okay, and again, what's a memory leak? Your program keeps running and keeps sucking up memory, never releases it to anyone else in the operating system. So at the end, it just has all the memory to itself. The computer comes to a halt, or just the operating system kills it, or in some way if it has that capability. So this kind of a thing does not exist in Java. Java has something called garbage collection, which automatically just cleans up those things for you. Okay, just so you know. So those are the memory leaks. Aggregate data types. Question?
So how is memory leak different from overflow?
Overflow is well, memory leak could lead to overflow, but yeah.
I thought they were
Yes.
hand in hand
Yes.
equivalents, yeah.
Yeah. Memory leak is basically you suck up too much memory and you don't release it. Overflow is you exceed the capacity of the memory. Okay, structures. I'm going to skip the structures. I do a little bit of introduction of structures in the regular semester, not in the summer one, for C++. And that's what the structures are. Okay, and I'm going to show you some examples of how and what we do in C++. Okay, so I went over Chapter 2, Chapter 3, these two PowerPoints. I showed you the floating point discrepancies. And I guess I'm going to show you a little bit about array deletion and insertion right here, because this is something that's very important. There you go. Okay, so, and don't focus on my syntax too much. Like maybe this is not exactly the way we should declare an array in C++ or whatever, but just imagine it actually is pretty accurate. So you have an array, right? This is my array, and the reason I'm saying that the syntax is wrong is that if I have declared an array like this, then the size of this array will be not 3. It will not be 4, but it will be 3. Okay? But suppose that I have a way to show my array. You have some kind of a function that shows my array. We did that in 45, right? Remember how you can show the curly brackets and then the array numbers and then the curly bracket at the end? So my show function uses the variable num_else to show these curly brackets, but the actual size of the array is 4. Okay, so that's what I mean with this here. So anyway, so suppose you have an array of, actually it's 4 things, but we're just showing it that there's actually only 3 things filled in there. So what I'm trying to illustrate here is I want to delete this one. I want to delete the 4. Okay, so which means I want to delete index 0. In order for when I delete it, what I want to do is I want to shift these numbers one to the left. So the 3 is going to go to the place of the 4. The 5 is going to go to the place of the 3. And then I'm going to change my number of elements to 2. So that if I want to go and do the show with this array, then it will show it just 2 things. Okay, the first thing is the 3 and the second thing is the 5. Okay, so to visualize how this deletion would work, just start with a very simple array and then list these different steps that you want to do. So the step 1 was move the 3 to the 4, so that means that A0 is equal to A1. So then you have 3 and 3 and 5. Then the next step is you make the A1 is equal to A2, so now you're going to have 3 at the beginning and 5 as the second, and then another 5 at the end, and then so that's how it ends up being. And then the next thing that I'm going to do is I'm going to say, okay, let me reduce the number of elements, so number of elements minus minus, and then when we try to show the array, it's going to show us 3 and 5. Okay, so there's the shift that you have to do if you're deleting from an array.
Where does it get the 5 from?
Which one? This one here on the?
When you shift it over, why does it take a 5?
Because you're moving this 5 here on the top to the place of the 3.
Oh, it does.
Yeah, yeah, and that's why the order of these shifts makes a difference. What would happen if I did this first? If I did this first and then this second, you're going to end up with a bunch of 5s. So if I move the 5 first and then I try to move, so if I move index 2 first and then I move index 1, I'm going to end up with an array of only 5s, right? And that's why it makes a difference which one you do first. So this is the basic shift of an array. We're going to be doing this kind of stuff quite a bit, so get comfortable with it. Okay. The other one is if you want to add something to an array, right? So remember the array actually has a size of 4, which means that even though we're showing it like this, the curly brackets are the 4, 3, 5. There's actually another slot after that allows you to insert another number. Okay. So how does the insert going to work? Well, kind of in the opposite direction. We started the last one first. We moved this one to the right. Then we move the second one to the right. Then we move the first one to the right. And then as soon as we're done with all these shifts, and I write it right here. So let's say this is my first shift. So that means that index 3 is equal to A2. So A3 is equal to A2. I shift to the right. Then I'm going to end up with the 4, 3, 5, 5. Then the next one is I'm going to shift the 1 to the place of the 2. So A2 is equal to A1. You end up with 4, 3, 3, 5. Then the last one is you shift the 4 to the place of the 3. So you have A1 is equal to A0. And then you end up with a 4, 4, 3, 5. And then the next one is, let's say you want to insert a number. We were trying to insert in the beginning of this array. So you insert a 10 in here. So that means A0 is equal to 10. And then at that point you have an array 10, 4, 3, 5. And then when you resize the array, or number of elements plus plus, then you can redraw the curly brackets like so. Make sense? Okay, so these are the shifts. And of course, we're not going to be doing it manually, so it helps if you label these different things. Like, for example, in here I had like a little I, right? This is my I, this will be the I plus 1. And the main thing is I want my I to go from where to where. If you look at this here, I goes from 0 to 1, even though I have num elements 3, right? So what I got to do is I tell it I starts at 0 while I is less than num elements minus 1, right? So that way the loop will go 0, 1, and then stop there. Okay? And then this one here, similar thing. You can just pretty much label which one's the I. This is my I column. This is my I plus 1 column, right? And then since you have to start at the last one, right? You start I is equal to num elements minus 1, right? You have 3 things, so num elements is equal to 3. So we represent the 3 by minus 1. 3 minus 1 is 2, and then it goes to I is greater than or equal to 0. Okay, so we want it to go to 0. Does it go to 0? Yeah, the I goes to 0. The I goes 2, 1, 0. Okay, and then you just do AI plus 1 is equal to AI, and then it does all the shifting for whatever size array you want, and that's it. Okay, so this is the insertion and deletion of arrays, deleting and insertion of arrays, and now let me tell you about objects. All right, I'm gonna open up this thing. Okay, so object is a concept in computer science. Anything can be an object. Human, car, table, room, you're an object. I guess that's a good time for a joke. Why did the programmer lose his girlfriend? Treated her like an object. There you go. Okay, so each object has properties. Those are the variables. Okay, so variables are the properties of the objects. And each object has actions, which are the functions that we've learned from C++1, right? So properties are the variables, actions are the functions. The way you change the properties are through the actions, right? So you have some kind of a dog and it has an age property. You would have at least a couple of actions to change the age or to look at the age, right? Maybe do something else, calculate, I don't know. Okay, and encapsulation means that the object properties should be hidden and can only be changed through its actions, right? So I don't want the outside world to go in there and directly mess up my age properties of my dog object or whatever, because what if I give you the ability to arbitrarily change the age to whatever you want, you might go in there and type hello world as the property of age, but that's a string. That doesn't make sense. So the only way that I would allow you to do that is through these properties right here. So if you look at this thing here, I have int age. The reason I made it private, right, is so that the outside world cannot go in there and directly type in hello world into my variable age. The only way they would do it is through this function called change age. Okay, so in this here example, I'm showing you what is an object. Okay, or actually, what's a template of an object? So that's a class. The way we describe how an object is going to behave, which is basically think of it as the template for an object, is using classes. Okay, so this is my class person, which describes what a person will be. To keep it simple, it will just have an age, and then at the very least, like I told you, at the minimum, you need to have a show age, change age to change this, and then there's a couple of, so these from C++, what do we call these things with parentheses? Void show age, what is that thing called? Huh? Function. No. Yeah, so but this whole thing, void show age, parentheses, that is a function, right? Well, once you put the function inside of once you have a function inside of a class, they like to call it method. What's a method? It's a function inside of a class. And there's there's this question in the Java class, which was, what is the difference between an object-oriented and a procedural language? What is an object-oriented language? Well, you have all these things. You have a bunch of variables and functions bundled up into something else called an object. Okay, so that's an object-oriented language. What is a procedural language? You don't have a class. The procedures, also known as functions, are just out there in the real world. In the world, they're not bundled up into anything. So that's procedural language is what we've done in CSIS45, pretty much. The entire class. An object-oriented language is now what we're going to be doing in this class. We're going to introduce classes. Okay, and the difference between C++ and C is actually the C language did not, well, maybe with the later standards it does support it, but originally the C language did not have classes. It had these things called structs that were kind of mentioned in the PowerPoint, And what is a struct? A struct or structure is kind of like a class, except you don't have any functions in it. Okay, if you want to, if you want to group a bunch of variables into something called whatever, some kind of a named entity, that would be a structure. Now, if you want to include functions into that named entity, then you have to use a class. Okay. All right. So, and I guess why don't I just show you some examples here? Maybe I'll do it in a little bit. Okay, so a couple of things. See this thing, person, with just parentheses. It does not have a return type. So these other ones here, you have a void show age, void change age. Void was what? Doesn't return anything. It's the return type. But notice that we have like a function underneath it, or a method, which does not have a return type, and it has the same exact name as my class name. Okay? So what is this called? This is called a constructor. Okay? When do we use the constructor? When we first create an object. Okay? So in this, say for example, this is my class and this is my main. Let's say I want to create a person called Alex. As soon as I say person Alex, this right here calls the default constructor, and in the default constructor is what we're going to use, is what we use to set the value of these properties, or the variables. Right? So as soon as I create a person with the default constructor, it will give it like a certain age, maybe 0, maybe 10, whatever, like a certain fixed value. So every time I create a new object, I can have a person Alex and a person Richard. Both of these people, since if they're created using the default constructor, which is this person with just parentheses, they're going to have the same age. If you want to create a new person which has a different age than the default age that I have in the default constructor, then you use an explicit constructor. Okay? Which means that instead of just person Alex, it's going to be, the way you're going to declare a new person is going to be person Alex parentheses, and then in the parentheses I give it some kind of a value, and that's going to be the new value of the age. Okay? And then later on, if I wanted to change the properties or show the properties, I just do alex.showAge. What's showAge? Well, it's this method that's part of my Alex class. If I wanted to change the age, I say alex.changeAge, which is this other method, which is going to change the age. And by the way, in this example here that I show you, I'm kind of following one of the ways that you could do this in C++, which is in here I'm just having the prototypes of my functions or methods, right? So just remember how in C++ we had prototypes before the main, and then underneath the main we define what these functions are supposed to do. So the prototype is just this, basically telling it, okay, there's going to be something called showAge. That's going to be the function. And then underneath the class, we're going to define what we're going to do in showAge. It'll be just like cout age, right? So that's one way to do it. Another way to do it, which I start doing later on, is the way Java does it, which is you just define the thing inside the class. You don't have to have a prototype and then define underneath the class, because that's just extra typing, and you'll see that too. Okay, so we get what objects and classes are. What's the difference between an object and a class?
Object's the container, and the class is the container, and the object is the functions of the class.
Object, so for example, class person is the template or the blueprint of what the different objects are going to be that we're going to create are. So in this particular case, person is my class, okay? Alex is my object. So from this class, I can create multiple objects, which are going to have slightly different properties. So we're going.
Person John, person.
I can have a person John, person Alex, person Richard, and each of them could have different ages, right? That's so.
What would the age be right now if you did a CL?
I don't know, because I don't see the I don't see what the default constructor is doing. right? So I think I have an example in there somewhere, maybe later on down these pages. But it really depends on how I defined my constructor, because I don't see what's in it. Could be whatever. Okay, so the age of Alex will be whatever I have set it to be inside of my person constructor.
Do you always need a default constructor, or can you only use, or can you only use explicit?
I think you could use only explicit constructors. I would have both just cause, right? But yeah, in Java, if you do not write a default constructor, Java will automatically create one for you, and it will make all the variables equal to 0, all the strings are equal to no, which is nice. But since C++ is not very nice, I'm assuming that it makes a default constructor and fills it up with garbage. Okay? Yeah. So if you don't want by default to create an object which is filled up with garbage, then make a default constructor in case you accidentally used it. Okay? So another name for an object is an instance. Okay? So Alex you could call Alex an object, or you can also call Alex an instance. Okay? The naming convention in most of these object-oriented languages is that classes start with capital letters, and pretty much everything else is with lowercase letters. Right? If you have a function, starts with a lowercase letter. Function or a method starts with a lowercase letter. Okay? So by the way, function, procedure, method, pretty much the same thing. If you hear me saying one, that's what I mean, all three. Okay? So that's that. And sample C++ program. Okay, so here you go. Let's have a look at this thing. So this is my class that you already saw from before. And this is how I'm going to define. So these are my prototypes for what these different functions, methods, / procedures are going to be doing. And I mean the names for them. And this is what they're going to be doing. Right? So how am I going to define what show age does? I say void person : show age. That's just the ugly C++ syntax of doing things. Okay? And then later on, what I'm going to do is I'm going to move these definitions in later programs. I'm going to move them into my class, and then it just reduces the syntax. And when you have these definitions inside of my class, then you can skip the person : part and just do void show age and then define it in there, and you're done. Okay? So anyway, what does show age do? Cout age. What does change age do? Well, it has a parameter variable new age, and then my age is equal to new age, so that whatever new age is equal to, that's what age is. Okay, this is my default constructor, which is this right here, the person parentheses. Notice there's no return type in front. It's just person : person parentheses, and then age is equal to 101. Okay, and then the next one is a definition of my explicit constructor, right, which is this person parentheses int new age. Right, very similar to what the actual change age does. Right? If you notice, change age has a new age, age is equal to new age, and the person constructor has age is equal to new age. Okay? So you might wonder, well, why would I want to have two things that are doing the same thing? Okay? So what is the difference as far as using it of change age and person? Well, person is the constructor. Right? So notice, right here underneath, I say person child parentheses 8. Because I'm putting parentheses, it will know that I'm trying to use this constructor. Right? Because I have an argument, right? My argument is the 8. Okay? When I'm saying child parentheses 8, because I am giving it a value inside of the parentheses, it will automatically know, oh, okay, I'm supposed to use the person constructor. Okay, the explicit constructor. Okay, you only use the constructor when you create a new object. Okay, so remember how Alex and child are both objects. Alex is created using the default constructor. So when I create an Alex without the parentheses, then that Alex is going to have an age of 101. When I have a child parentheses 8, then the age of the child is going to be 8. I only use the constructor one time, when I create an object. Okay, so I cannot use this constructor any more times on child, right? I used it one time when I created it, and then after that, if I wanted to change the property of the child, I have to use my change age method. Okay, so the difference between these two, the change age and the person is used when you create an object, change age is used after you have created an object so that you can modify the object to something else. Okay, so that's that. Yeah, and one more thing. So remember, I said that Alex and child are both objects of the person type or the person class. They're also called instances. So whether you say an instance or an object, think of the same thing. When you make a new object, it's called instantiating or instantiation. Okay, just so you know, there's that. Okay, and all that stuff is basically an explanation of what I told you here. And again, one more time, the way you access these methods that belong to the objects is through the dot. And that's how it's done in pretty much every object-oriented language, right? Python is object-oriented, Java is object-oriented, C++ is object-oriented. Pick an object-oriented language. Chances are you make an object in a similar way here, and then you access the actions or the functions of that object using the dot, and that's it. Okay. Technically speaking, if I had not made my variable private, right, I could also access it using the dot. So I could say alex.age, and that would allow me to change the age directly from the main. But remember that what if I go in there and type in hello world for age, I'm going to make the program crash. So ideally what I want to do is when I have a change age function or a method, what you want to do is you want to make sure that it's within a certain acceptable range of values. Maybe the age needs to be between 0 and 123, right? And for anything else, it'll tell you, nope, I can't do this. That kind of stuff. Okay? So that's the reason why we make things private, right? Variables that cannot be accessed directly through the object are private, and this is what you should be doing. That's the good practice. And then the way we modify these private properties is through the public actions or functions. Okay? Questions?
So you can like change it with the public function, so you can't make like private functions?
You could make private functions too.
So private functions, how they wouldn't work?
The private functions will be something that's meant to work only from within the class. And the purpose of a private function will be to use something with a, so you would have a private function, and the private function will be accessed through a public function. So you would need a public function that gets a hold of the private function, and the private function does something, right? Maybe some crazy calculation that you want to do for a person, but you don't want the outside world to like really see this. That's kind of the encapsulation idea. You know, you hide the details of what you're trying to do deep inside of the object. You only want like the basic interface. So what like the remote control is the interface for the TV, right? You don't want to have like every possible thing you could do with the TV. Some of these crazy functions that the TV is doing are not really accessible through the buttons. But when you press the button, pressing the button accesses those buried functions that do some kind of a magic that maybe changes the brightness or whatever. That make sense? Yeah. Okay. All right. So that's your introduction to object-oriented programming. Any other questions? Okay. So what's the difference between a class and an object?
Class is a template.
And an object is the actual thing that we create from the template. Awesome. All right. Closing this. And let's see what else I got. All right. So next thing that I'm going to tell you is encapsulate. All right. Let's see what this is. Okay. All right. So encapsulating an array. So remember, encapsulate means two different things actually. Okay, one of the meanings is what I mentioned to you, and it means to hide the array inside of a class, right? So we're going to have a pointer to array, right? And remember how in that PowerPoint that I showed you how we make dynamic, when we want to make a pointer using dynamic memory allocation, when we make an array using dynamic memory allocation, we use a pointer, right? So we make a pointer, and then later on you say this kind of stuff, like, so for example, int asterisk array, and then in my constructor I'm going to say array is equal to new int size, and what is going to be size? Size is something that maybe the user types in as the program is running. Okay, the reason we're using pointers is because there's no other way to do this kind of a business. Okay, the only way for you to create if you want to encapsulate an array, which means, so another meaning is, so you're basically hiding the array inside of a class, right? So this asterisk array is a pointer to an array, which is basically an array, okay? And so that's one of the meanings. The other meaning is the bundling of properties and functions. So just like we had age and change age and show age, the age variable is coupled with different things we can do with it. So that's the encapsulation. One meaning is hiding, and the other one is bundling of actions and properties. Okay, so let's have a look at this first, this example of encapsulation. So we have encapsulated an array, which means the array is inside of a class, right? We're using a pointer array because that's the only way for us to do this line right here. Array is equal to new int asterisk square bracket size. So the only way for us to create an array of certain size as the program is running is this way. Okay, we're going to have another variable called number of elements. Okay, and the number of elements is going to kind of keep track of how many things we're going to add to the array, right? So we can create an array of size 10, but initially there's nothing in it. So number of elements is equal to 0. That makes sense? All right. So, and then later on, what I'm going to do is I'm going to be adding elements to that array. So let's say, all right, I have an array of 10 things, and I'm trying to make the first number equal to 1. Well, this number to add will be the 1, and I'm going to say array number of elements is equal to number to add. Number of elements starts at 0 in the beginning, so I say array 0 is equal to whatever number I'm trying to add, and then number of elements plus plus just tells it, okay, now the index for the next thing we're going to be adding is 1. Make sense? Okay, and there's a function in there that shows the array with the curly brackets business that I was kind of mentioning earlier. Okay, so let's have a look at how this thing works. So let me zoom out a little bit. Okay, so I have encapsulated array and array parentheses 5. And you were asking me if we need a default constructor. There's the answer. No. Right? So you don't need a default constructor. We only have an explicit constructor in this particular case. So what I'm doing here is I'm saying encapsulated array and array 5. So which one of these is my class and which one is my object? Okay, an array is the object, right? And what I'm saying is I'm telling, okay, get the number 5 and send it into the default constructor. The default constructor accepts the number size, so it's 5. And I'm saying array is equal to new int size 5, so now we have an array of 5 elements. But we haven't added anything to it yet, so number of elements is equal to 0. And that's that. Okay? So then what I'm going to do is, next one is I'm going to add something to the array. Okay? So I'm going to say an array.add 9. Okay? What does the add do? It's going to take, we're going to send the number 9. Number to add is equal to 9. Array number of elements, which is 0 initially. So array 0 is equal to 9. And then number of elements plus plus, now the next index is going to be 1. So if I want to go and say an array show, it's just going to show me 9, curly brackets, 9, curly brackets. And that's it. Right? Then I go and I say, all right, let me add a 101. Okay? So I'm going to get number to add is equal to 101. array number of elements was increased to 1 already, so array 1 is equal to 101. Now I'm increasing the number of elements to plus 1, so now it's 2. If I want to add another number, let's say another 9, okay, number to add is equal to 9 again, so number of elements was 1, 2, now it's, what is it, 2, right? So array 2 is equal to 9 now again. And if I do an array show, then that's going to show you basically curly brackets 9, comma 101, comma 9, then close the curly brackets. Make sense? Huh?
Is there a limit to how many? Can you scroll back up?
Yep.
Is there a limit to how many numbers of elements you can add as?
The limit is size. Yes. So in reality, actually, it would make sense for me to have a number of elements variable and also to have a size variable. That way I can keep clear track of how many things I can add and how many I have added already. Right? So the size is how many total I can add. Number of elements is how many I have added. Okay, good question. Okay. So these are just really basic programs. I haven't like really made sure that like in my add, right, in my add method or function or procedure, it would make sense for me to check to see if number to add is less than size, right? Because that way I don't want to be adding 6 things to an array of 5 because it's not going to work. I'm going to do the index out of range business. Okay. But I haven't because I'm just trying to keep these as simple as possible. Question?
So the encapsulated array, encapsulated is like a function that makes the dynamically allocated array, so you don't call it more than once, or else you could like
Encapsulated array. Say that again.
You go back to the like see how it says encapsulated and it says the same thing.
This one here?
It's like a function, like it's written like a function, isn't it?
So you're saying encapsulated array, colon, encapsulated array? That's what you mean?
Yeah.
That's your constructor.
Okay.
Yeah.
That's the constructor.
That's the constructor. So the constructor, again, constructor is just another function or method or procedure which has the same exact name as my class. You see, encapsulated array class, encapsulated array function, which is actually the constructor. So when I say the name of the class, colon, the name of the class again, that's my constructor. Okay? And then all the other methods like add and show, they have the name of the class, colon, the name of the function or method. Okay? So that's that. And again, dynamic versus static array. This is an example of a static array right here. You're just saying int num is equal to 10. And dynamic array is you're basically saying int asterisk num is equal to new int 10. So we're still making an array of 10 things, except this one, with a static array, memory is allocated at compile time. And with dynamic array, memory is allocated at a runtime. Okay? There's no way for me to use this kind of a syntax, a static array syntax, when I'm doing this kind of a thing. Right? I cannot say array, square brackets, some size inside my constructor. And that's why we're forced to use pointers in C++. Okay? For making arrays. And that's pretty much it. As far as encapsulation, what is the meaning of encapsulation? Hiding the array inside of the class, and then bundling the array together with functions that let you operate on the array. Okay? Got it? Questions?
Back to the down at the bottom where it said it was like the last picture. No. So like there it says in the public, like so you can put it in the class, the function of the constructor.
Yes. Okay. Good. You noticed it. Right. So look. Good point. I kind of went over that. So notice there's 2 ways for me to define the constructor. One way for me to define the constructor is outside of the class. So it's like I'm saying, okay, there's going to be this constructor. This is going to be the explicit constructor, which is going to take one integer value. And here I'm defining what this constructor will do. So this is one way to do it. Okay, and I personally don't like this way because it requires me to write this encapsulated array twice, and I have to throw in some columns in there. Another way to do this is this. You just put the definition inside of the class. That works fine for me too. That's the way Java does it.
That looks like it would make more sense.
It does to me too. So, I mean, I'll show you, I kind of show you both ways, you know, just like I showed you. Here's what header files are. And then we're never going to use them really. But then, and then I'm going to show you here's how we can do, you know, one way to create a constructor, or, you know, to work with classes. And this is the other way. I like this way better. I like the Java way better. Sorry. Okay? So to me, this makes more sense. So if you want to define all your methods or functions or procedures inside of your class this way, you could, right? So you can, all of these other ones here.
So can you do that for all the other ones?
Yes, you can do that for all the other ones. So the add can be defined directly inside my main here, inside my class. The show can be defined directly into my class also. So to me, it saves just typing all this encapsulated array colon.
Is there any reason you wouldn't do that? Like, is there like a way you couldn't change the function if it's outside of the class?
No, just multiple ways to do the same thing, just like a lot of stuff with C++, right? And that's why a lot of languages have kind of gotten rid of all these extra, you know, things, extra different ways that you could work with something the way that C++ does. All right, C++ actually has more than one pointers. Right, this is one kind of a pointer. They also have a left pointer, a right pointer, and that wasn't enough. So the latest C++ standard came up with another kind of a pointer. Let's not even go there. Okay, so we'll stay with one kind of a pointer, and we're going to use the pointers as little as possible for what we're going to be using. All right, so that's that. And again, you saw the application of pointers can serve different purposes. You can create a dynamic array, or you can create, you can use it to change local variables from different functions. You can make 2D arrays, all kinds of different things. Okay, so that's that. That's the encapsulation. So now we know what an object is. We know what a class is. We know what an instance is. We know the difference between a static and a dynamic array. We know what it means to encapsulate an array. Okay. We know how to delete and insert. We know a little bit about the pointer arithmetic and what it means to have memory leaks, right? And I guess let me have a look at this little lecture note that I have in here, which is, yeah, the clown, whatever. All right, so this is just another example of an object. All right, so I have a clown, and the reason I did this is because I teach game development also. All right, if you take the game development, will be offered next semester in the spring 18. All right, it's an easy way for me to illustrate what an object is to novice people who don't know anything about object-oriented programming. You basically have like a room, and you create a clown or whatever. Like the first game that we create is a clown. The clown has some kind of a picture of a clown in it, and then the way you place this thing inside of the room is just like a square. The clown can move around in the room, right? And the property of the clown is the picture. What is it going to look like? And the other properties will be the position of the clown, right? Where is it? The XY coordinates inside of the room. Okay. So you have your clown constructor, right? The explicit constructor, which can take, the explicit constructor does not have to necessarily have just one parameter. You can have multiple parameters depending on however many properties you're trying to change. Okay. Yeah. So I have a change position. So here we go. We have a picture. This is my default constructor is going to make me a clown with this picture, like some JPEG file, right? And this is going to be the default position of the clown, maybe someplace in the center of the room. Okay? And then I'm going to have an explicit constructor. We're still going to use the same picture, but we're going to use different position for this clown, whatever the user desires. Once the clown has been put inside of the room, we can move it around different places. We can have it bounce around the room, right? And that will be done using the change position. Okay. And you can also show the position of the clown using the show position method. Okay, and in here I also have a bubble sort. Not sure why I'm showing you the bubble sort in here. Okay, and then some examples of memory of pointers. All right, so I'll wait for the bubble sort until later, but well, I guess I'll just tell you a little bit about it. You already any of you remember the bubble sort from before? Kind of. Okay, it's basically if you go and you just Google bubble sort, all right, and just look at the Wikipedia thingy, you're going to see, there you go, you have a list of numbers. You're comparing the left to the right. If the left is bigger, you swap their values. You keep moving down and down and down. So by doing this, the biggest number moves all the way to the right or bubbles up to the top. Then you go back to the beginning, you repeat it again. Now the second number moves to the second place to the right, etc., etc. And when it's all done, right, the loop, this loop right here is to compare two numbers that are next to each other and then move one down, move one down, move one down so that it goes all the way to the end. And then this one here is to repeat this thing all over again, right? So the first one is this piece that's happening right now. So when we're moving one number all the way to the right, this was the inner loop. Now we go back to the beginning. That's the inner loop has done its job, and then now the outer loop increases by 1, and we're going to do it again. And we basically repeat this thing until the whole thing is sorted. And that's your bubble sort, right? All you're doing is you have an array of numbers, right? And you're comparing the left, this is my I, to the right, which is the I plus 1. We have a size -1 because you don't want the I plus 1 to go too far outside of the array, because then things start getting weird. And I have kind of broken it down into little steps so that you can walk through this if you want to see how it works. That's that. And then I have some examples of, you know, how you make a clown called Alex, and there's another clown there, right? And how you change the position of the clown, how you can show the position, how you make a clown using the explicit constructor. So this is the default constructor, this is the explicit constructor, okay? And then some more memory stuff or pointers, right? This is my variable a, right? When I show you a initially, it's a 0, right? If I say, let me zoom in on this thing. All right, so if I say %a, that will actually refer to the memory address of a, right? Here it is, I'm declaring a pointer called a. If I say %a, you're going to see that that thing also has some kind of a memory address. We really don't care about this one though. When I say cout a, it's going to show me some other memory address. This memory address here will be overwritten by this one here. Okay, so when I say a is equal to %a, I'm actually making the pointer a equal to the memory address of this variable. So now if I do a cout a, you're going to see this, which is the same memory address as my a. So that means now at this point a refers to little a. Big A refers to little a. When I do *a, I'm actually accessing the content of the little a. Okay? When I do *a is equal to 10, I'm overriding the content that was stored inside of the variable a. Okay? So just some examples of pointers. And then there's another example of, this is a static array, and this is my dynamic array here, right? So two different ways to make an array, and that's about it. Okay? So just a little quick review of pointer arithmetic, and so you don't look too confused. So let's have a look at what I have here. Okay, so I'm keeping it pretty easy, I think, I hope. Okay, so type up the sample program below and get it to work. Okay, add the private property weight. So I have a person, the person has an age. I'm asking you now add another variable called weight. It's going to be a decimal number, so you can make it a float or a double, whatever you want. Okay, and we're going to do some actions which can show the weight and change the weight. Okay, so I give you an example of how you have an age property and how you show the age and change the age. Similarly to this, you have to change the weight using show weight and change weight. weight. Okay? Yeah, that's it. That's all you have to do. I didn't say anything about making an explicit constructor, so I guess you can also change the constructor if you like, right? Right. In here we have a person that only makes the age equal to 101, and allows you to set an initial age. You could expand the constructor just like I showed you with the clown to include also the weight. Okay. So use the clown example that I just showed you, the lecture notes from before. That's one. And then the other one, P3, huh?
25 years later, after waiting for it to load.
Yeah, you gotta wait for Canvas to think about life. One of the reasons we switched to Canvas is supposed to be, oh wow, it's so much faster. Let me go to my server. Oh wait, I'm already in. That's how much faster Moodle is. Which class do you want to go to? This thing's still loading. Which assignment do you want to go to? Hold on, this thing's still loading. So yeah, the reason why the college got sold on Canvas is because it's supposed to be so much faster. You see this? I logged into my class, I went into, I logged into my server, I logged into the class, I opened an assignment, and now it loaded. All right, I'm gonna send this video to Tom Rebold at MPC, because he's this really smart guy who graduated from MIT but never used Moodle and loves Canvas, and I love giving him a hard time about that Moodle is actually really faster. Okay, so I'm gonna send him this video, and I'm gonna tell him what part of the video to watch. Let me try to remember. That's 110. I'm almost done. All right, so another example here. We have type up the program below and get it working, then add the following functions, methods, / actions, right? Also known as procedures. So function, method, action, procedure. When you hear it, same thing. Okay? I'm asking you to do an insert first and a delete number. Okay? Insert first refers to that picture that I showed you of how you insert into an array and how you delete from an array. So use that. Delete a number also refers to that picture that I showed you of how to delete from an array, and use that. Okay? So insert first always inserts the first one in the very beginning of the array. You can insert anywhere you want in that array, but inserting first requires the most shifting, so let's do that. And deleting number requires you to find which number you're going to be deleting, and then deleting at that spot. Okay, and the sort allows you to sort the array using bubble sort. I guess that explains why I showed the bubble sort in the lecture notes. Okay, and that's it. So then you're giving you the basic thing. Oh, and there's the pictures of this stuff, and that's that. And if you get stuck on this, I think it's a couple weeks down the line. I'm done. I promise. I'm almost done. 4, 5, just to show you where this stuff is. Not there yet. Week 5. Solution P3 array encapsulation. So yeah. So the second one, which is a little bit harder, I provide the solution in here. So if you get stuck on it, look at week 5. Okay? And I'm going to do that for all of the assignments. All right? So I'm going to give you an assignment, and a couple weeks later, you get to see the solution in case you get stuck. Okay? Yeah, no problem. Just don't take advantage of it too much. It's very important for you to learn how to solve these on your own. Only if you absolutely get stuck, look at the solution. And if you find yourself looking at the solution, once you're done with the problem, do it again. And this second time that you're doing it, you don't get to look at the solution. If you look at the solution again, do it a third time. That's seriously, that's how it works. Okay, until you're solid, until you got, all right, I got this, I can do this. Okay, when I went to USC, I actually did my chemistry homeworks 3 times. 3 times. All right, and that class was so damn competitive that I still got a C on it. Just so you know. Okay, so that's what happens when you go to like these fancy top schools. If you want to go to Berkeley, that's what's going to wait for you there. Okay, you want to go to UCLA, you want to go to Stanford, that's what you're going to have to deal with. All right? Just so you know. If you go to CSUMB or San Jose State, not as competitive. All right? So you're still going to get a bachelor's or whatever, but Now I'm gonna make you sweat blood until the end. All right.